Hi ladies, today we are going to talk about multiplying and dividing monomials. So we are back in chapter 9. So multiplying and dividing monomials. The first question I'm sure you have is, what's a monomial? A monomial is just a single term, mono, one. So for example, we could say the number 5. That's a monomial. Or you could say negative y. That's a monomial. Or you could say 4x. It's just a single term. It's either a single number, a single variable, or a product, which remember means multiplication of a number and a variable. Okay. Binomials, bi means two. Think of bicycle, bicentennial, biweekly. So bi means two. So if I had two terms, I might have something like 5 plus x or 4x minus 9. That's when I would have two terms and they're separated by plus or minus signs. So that's just a little bit on the vocab there. We're going to be working with powers today, and we're going to look for some quick tricks we can use to simplify multiplication and division. So let's just go ahead and take a look at something cool. Like, let's say I am multiplying 4 cubed by 4 to the 5th, and I'd like to know what this product happens to be. Please recognize that 4 cubed means 4 times 4 times 4, and that 4 to the 5th means 4 times 4 times 4 times 4 times 4. Okay, lots of 4s. And what am I doing with these? I am multiplying them together. So instead of saying 4 cubed times 4 to the 5th power, I can simplify this. I can go, hey look, I have 1, 2, 3, 4, 5, 6, 7, 8 4's being multiplied together. So I can say that this is equal to 4 to the 8th power. Okay, and I am just simplifying. I'm not going to actually calculate at this moment in time because, again, I can use a calculator for 4 to the 8th. But I want to recognize what's happening here. Let's take a look at something else. Let's say we have negative 9 squared times negative 9 to the 3rd power. Well, what's happening in this case? Remember that parentheses matter, especially around negative bases, so you must include them. This is not the same. Just remember, this is not the same as these. You get two different answers because remember, in this case I'm taking negative 9 and multiplying it by negative 9, giving me a positive 81. And remember that in this case what I'm really doing, following the order of operations, is 9 squared and then multiplying it by negative 1, which would give me a negative 81. And that's why you can see that these are not equivalent. So that's an aside. We've talked about that in the past, but it's something good to mention. Okay, so we need to keep the parentheses. They do matter. So let's say I have negative 9 times negative 9 here, and over here I have negative 9 times negative 9 times negative 9. I'm multiplying these together, so how can I simplify it? Well, I have 1, 2, 3, 4, 5. This is negative 9 to the 5th power. So again, this is simplified. Do you notice a pattern here? I'm keeping the same base each time. But what am I doing with the exponents? Can you figure that out? It turns out that when you are multiplying powers with the same base, you can simplify them by adding the exponents together. That saves you the step of writing out 4 times 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 4. So if I gave you something, like this, 20 to the 30th power, times 20 to the 10th power, you don't have to write 20 out so many times. You can recognize that, aha, here I'm multiplying 20 by itself 30 times. Here I'm multiplying 20 by itself 10 times. So altogether, I'm multiplying 20 by itself 40 times. And that's a quick way to simplify. This breaks down into a rule. Let's go ahead and highlight it. It's called the product of powers property. Lots of P's. There's some alliteration for you. So product of powers property. So we can multiply powers with the same base by adding their exponents. can multiply powers with the same base, and that's really important. We have to have the same base. You can't combine two powers that have different bases, and I'll show you an example why in just a moment. By adding their exponents. And algebraically, we can look at it like this. If you have a to the m times a to the n, this is equal to a to the m plus n. So this is the rule right there that we would like to follow. Let me just show you an example of why we can't do it with different bases. So for example, if I asked you to simplify something like this, negative 9 times negative 9 cubed times 4 to the third. Okay, well here I have negative 9 times what? Well, negative 9 cubed looks like this, and then 4 cubed looks like this. So here I'm just writing it all out. I can recognize here that I am taking negative 9 and multiplying it by itself 4 times, but I can't combine it with the 4 cubed. I can't say, oh look, here I have it 3 times. 4 plus 3 is 7. I can't combine it that way because I'm not going to get an equivalent answer. Whatever negative 9 times negative 9 times negative 9 times negative 9 happens to be, that is independent from what 4 times 4 times 4 happens to be. You can go ahead and grab a calculator and I'll just show you. Negative 9 to the 4th power, you can type that in. Let me flip to the next page so I have a little bit more space to continue on. So negative 9 to the 4th power, let me just remind you how to do that in your calculator. You're going to type in parentheses and then that little negative sign, 9 parentheses, and then you use the caret button, which is underneath clear, to the 4th. And when you do that, let me just go ahead and do that here, you should get 6,561. 4 cubed will be typed in 4 caret 3. And you could probably do that in your head because 4 times 4 is 16 times 4. You can use the distributive property there and you will get 64. And then I would have to multiply these together to get my final answer. And let me go ahead and do that. And you will get, here I am, 419,904. Remember to use commas so you can read your numbers. So what I was saying before, you can't just say, oh look, let me see if I can combine this further. How about I do negative 9 times 4 and then put it to the 7th power? This is going out of order of operations, but sometimes people like to do what they think they can do. And I'll just prove to you here that you don't get the same answer because negative 9 times 4, if you did that first, you will get negative 36. And when you put negative 36 to the 7th power, remember you do want to keep it in the parentheses. You're going to type this into your calculator and get a number that's in scientific notation. It's going to look really funky to you. Something like this, negative 7.836, and it goes on, and then it says E10, and that just means that it's in scientific notation. So we could write it out here, times 10 to the 10th power. A very, very large negative number. You can see that it is clearly not the same thing as 419,904. So just make sure you're not making up your own rules. You need to keep the same, you need to have the same base in order to apply this property. There's another rule we can look at in terms of division. So let's go ahead and look at that. So for example, if I asked you to simplify, and we've simplified algebraic fractions like this before, but let's say you had a to the 4th power being divided by a to the 3rd power. Usually we would factor all of this out, a times a times a times a, and this works, all over a times a times a. And you would start simplifying. A divided by a is 1, a divided by a is 1, a divided by a is 1, and you are left with a over 1, which simplifies to a. I'm going to put the power here. Remember that whenever you don't have a power, it is just a to the first, because I would like us to see if we can find a pattern. So take a look at those. Let's try it with something else. Let's say we wanted to take m to the 5th power and divide it by m squared. So I'll do the same thing. Again, it takes up a lot of time. 1, 2, 3, 4, 5. Make sure you get all of your m's written down. All over m times m. I can simplify out, and this time I get 1, 2, 3, m to the 3rd power. So can you recognize what's happening here? We again have the same base. Do you notice a pattern with the exponents? It turns out that we can subtract. A to the 4th divided by a cubed gives you a to the 1st power, or a to the 4 minus 3, which is 1. M to the 5th power divided by m squared gives you m cubed, and that's derived by subtracting 5 minus 2 to get the cube. So again, it's another rule that just helps us be more efficient mathematically, so that we're not factoring out tons and tons of variables. So for example, if I asked you to simplify x to the 44 divided by x to the 30th, you don't have to write them all out and cancel them all out. You can subtract 44 minus 30 and you will get x to the 14th. And this is a true statement. So this rule is called the quotient of powers property. Remember, quotient meaning division. So we can divide powers with the same base by subtracting their exponents. So you can divide powers with the same base. Again, it only works if they can evenly cancel out. Same base by subtracting their exponents. And if you ever forget the rules, just factor them out and figure them out that way. You don't have to know the rule here to figure out this problem. It is faster, and I do want you to learn these rules. But if you get confused and you're like, wait a second, do I add or subtract? Set a problem up for yourself, a simple example, and go, oh right, I would be subtracting when I'm dividing. In symbols, algebraically, a to the m divided by a to the n is equal to a to the m minus n. So again, this is the other rule we will be working with. A couple of other neat examples just to show you really quickly is, we can make them a little bit more interesting. So I'll say simplify, and it's more applying these rules, not as much, can you calculate what 9 to the 14th power happens to be. So again, make sure you're focusing on just the simplification. Let's go ahead and do something like this. Let's say I gave you 4x cubed times 5yx to the 3rd. Okay, so this is a cool one. Remember, we have to employ all of the properties we've been working with, including the commutative, associative, distributive properties. Here you need to see that you have all multiplication. This is all multiplication, so I can use the commutative property to rewrite everything. There's no distribution because I'm not multiplying over a over a sum or a difference. So I'm just going to rewrite this. I'm going to put my numbers together, 4 times 5 times x cubed times x cubed. I'll put my x's together, and then times y. Y is just going to hang out. So I'm using the commutative property of multiplication. And now I can simplify because, again, this is all multiplication. 4 times 5 gives me 20. Here I can employ the rule because I have the same base. So x cubed times x cubed is going to give me x to the 6th. Remember, we are adding these exponents times y. And y cannot be combined with anything else. Okay, and there we go. I will see you in class where we will practice more. Thank you very much.